Okay, this is a video response to Veritasium's 4 revolutionary riddles. I'm pretty sure I've got the answers to all of these, so let me go through my working out. This is number 1, which is the mystery cylinder. This thing that rolls down a hill, stops, and then after a little while starts rolling again. My hypothesis is that there is a really viscous liquid in there, something like treacle or maybe honey would even do the job. So that here at the start, when the liquid is level, the center of mass of the cylinder is in front of the point of contact. So it's going to roll forward. But here as it spins, the liquid is stuck on the back of the cylinder and it moves so that the center of mass of the cylinder is going to be somewhere back behind the point of contact on the ground. So it's going to stop, maybe even move slightly uphill. After a little while, when the liquid slumps back down, it goes into this position where it starts rolling again. Because again, the center of mass is above or in front of the point of contact. In riddle number 2, you have a string tied to the bottom pedal of a bike sitting on the ground. Say you pull that string backwards, what direction will the whole bike move in? Now I think that the bike's going to move backwards. Now you might think, well, if I move the pedal back this way, that's the direction that I push it to make the bike go forward, so maybe the bike should go forward. But also maybe you're thinking that if you pull back this way but the bike's trying to go forward, they'll cancel out and the bike will go nowhere. Well, let's look at a couple of points here, the bottom pedal itself and a point here on the bottom of the wheel. Let's for a moment say that the bike does move backwards. So this wheel is going to move around a little bit, this point on the wheel is going to rotate up by some angle, theta say. Now, if we simplify for a moment and say that the gear ratio here is the same on the wheel and the pedal, it probably shouldn't change very much. Then the pedal is also going to move by the same angle theta. But because the circle that the pedal describes as it moves through space has a smaller radius than the radius of the bike, the distance that it moves, x1, is less than x2, the distance that the wheel moves. So x1 is less than x2. So even though the pedal is actually going to move up and forward relative to the rest of the bike frame, because this distance is less than the distance the wheel moves, the whole pedal will move backwards relative to the ground. And that's what matters. So the bike itself will move backwards. Riddle number 3 asks, say that you run around a track in some slow speed. How fast would you have to run around the track for a second lap so that your average speed across the two is twice your speed during the first lap? Now my immediate thought was, wouldn't you have to run infinitely fast? So I did the maths to check. Your speed over the first lap is the distance divided by the time. Pretty obvious. Average speed is 2 times the distance, because it's 2 laps of the same track, divided by the first time plus the second time. Now if we say that this is equal to 2 times the first speed, we have this expression, these 2's can cancel out, and we have an expression for the first speed. But we already have this equation, so in order for these to be equal, t2 here must be 0. Which means that you're running infinitely fast, and because you cannot run faster than the speed of light, which is a constant value, this is impossible. The last riddle asks, what part of a train moving at any speed is moving backwards relative to the ground? If we look at a train wheel, we see that it's sitting on the track on a thinner inner section. So there's a wider outer part, and that's not actually for keeping the train on the track unless it's an emergency, as Richard Feynman so famously explained. But it's this part here that when the wheel spins, moves backwards relative to the ground. And I've got a really exaggerated example here that I've mocked up that we can use to illustrate that. So as I spin this wheel around here, it's quite clear to see that the bottom parts, the outside parts, which have a larger radius, are moving backwards relative to the ground. This is the outer part of the wheel. The flange, which doesn't touch the track. I hope I'm right.